Hello, grade 10. So we are going to explain in this lecture our lesson coordinate system. First of all, you know that any point on the axis, it has a directing vector and a coordinate on the axis of abscissa. We called D, the line D is the reference and the axis. O is the origin and I is the directing vector. So any point on this axis M, if you can see M, it has a coordinate x and a directing vector I for the axis of abscissa. If I have, for example, OM equals 2I, then the abscissa of M is 2. If I have I, then the abscissa is 1. If I have a vector OC minus I, then the coordinate of C is minus 1. If I have 2 points A and B on an axis, the vector AB, it is xb minus xai. Example, if I have xa equals minus 5 and xb equals minus 3, so vector AB is xb minus xa. So minus 3 minus 5 is equal to 2i. Another example, if I have xa equals 6 and xb, I don't have it, but I have that ab is minus 10. Then ab equals xb minus xa. So it's just calculation, and now xb equals minus 4. Now the distance between 2 points. The distance, you know that the magnitude of the vector I is 1. So in order to find the distance between the 2 points, it's enough to find the distance xb minus xa in an absolute value because the distance cannot be negative. Planes and reference. So suppose we have a 2D plane, or in another word, the axis of abscissa and ordinate. So now any point M, it has coordinate on the x-axis and coordinate on y-axis. So you will get OM equals xi plus yj. So as we have the vector I on the x-axis, we also have j on y-axis. So look at this figure. I have point M. So OM, it has xy coordinates. In another example, if I have a point A that has minus 3, 2, then the vector and the vector u, which is 2 minus 1.5, then OA equals minus 3i plus 2j, and u has 2i minus 1.5j. Equality of two vectors. When do I say that the vector v is equal to the vector u? We say that two vectors are equal if the coordinates are equal. So if x equals x prime and y equals y prime, then the two vectors are equal. You can add two vectors if you just add the x coordinate together and the y coordinates together. So point A is 2, 3, point B is 5, 2, and so on. So I have A, B, C, D, and we want to show that the two vectors are equal. So first of all, I have to find vector AB. You know, it's xb minus xa, yb minus ya, so it's 3 minus 1. CD is 3 minus 1 also. So yes, we can say that the two vectors are equal. When do I say that two vectors are collinear? Suppose I have two vectors u and v. We say that u and v are collinear if we find something called the determinant, where do I place the coordinates of the first vector above and the coordinates of the second vector below. And if I get xy prime minus x prime y equals to 0, then the two vectors are collinear. Three points collinear. If I need to prove that 3 points are collinear, I need to form two vectors of these 3 points. So I can choose AB, AC, AB, BC. So you can choose any two vectors that includes the 3 points, and then you find their coordinates and you check the determinant if it's equal to 0. And the distance of AB in 2D plane, it's xb minus xa squared plus yb minus ya squared under the square root. And now how do I find the midpoint of a segment? Let I be a midpoint of AB, then xi equals xa plus xb over 2, yi equals ya plus yb over 2. How do I find the center of gravity? First of all, three non-collinear points, they form a triangle. And if I need to find the center of gravity of this triangle, it's enough to say that xg equals xa plus xb plus xc over 3, and yg equals ya plus yb plus yc over 3. If I now need to translate the vector from the origin into another point, so the original reference is center O, I, J. Now the new reference, we are going to choose another point. So now the coordinates of the points will change. Look at the figure. That was our old system. We created or we translated the system into a new origin. So now I will have a different coordinates for the point M. How do I calculate the new coordinates of the point M? There is a rule that says that the new coordinate is equal to x old plus x prime. Let us take an example, and also the y, the same thing for the y. I have the point M minus 2, 3 in O. Now I have M in O prime. So how do I calculate the new? Well, the new origin is minus 1, minus 2. So we can say that minus 2, which is the old coordinate of M, is equal to the origin, our new origin, plus the new coordinate for M. And the same thing for the y, and that's how we calculate the new coordinates of M in the new system. Another example I have. We substituted x and y in one equation, so you will get y prime equal to x prime. This is the equation of a straight line. How do we translate it in the new system?